Now if you think back to the t-test, the big dividing line was whether or not the variances were going to be similar. Now in 1, we assumed that the variance was basically 0 for one of the two. We just said, hey, look, this single value we're comparing it to is so well known, it doesn't even have a standard deviation. That was case 1. So, case 2 of the t-test, we said, again, there's not going to be a big difference between our variances for both of these measurements. But in case 3, we specifically went out of our way and said, yes, in this case, the variances are different. And of course, variance is related to standard deviation, so that also means the standard deviations will be different. Now that means that before we ever did any of our t-tests, the first thing we should do is an f-test to decide, are our standard deviations the same? And they don't have to be exactly the same. They just have to be similar enough that we can say, yep, these are similar enough. The difference is random chance or sample size related. We're in good shape. We can now safely ignore the standard deviation and focus on whether it's case 1 or case 2. Case 3 is what we'll choose if it fails the f-test and we or passes the f-test, however you want to look at it, and we do say the value of f has exceeded the value of f table. Now you can see the calculation for Fcalc is actually really simple. We're going to take the larger of our two standard deviations, and we're going to square it. We're going to do the same thing to the other standard deviation. We're going to square that. We're going to divide the larger square by the smaller. Notice that means we're always going to get some value that's going to be larger than 1. So as you go further into your equations booklet, you'll find a series of f tables. And notice that we have a different table for each of the confidence intervals. And at the very bottom of that page of our book, you'll even see that I give you the equation in Excel 2010 to go ahead and calculate it yourself so you can create your own table whenever you want. For our purposes, let's just stay up here on the 95% confidence level, just to have one to actually look through. Now what we're going to do is we're going to take the one with the larger variance. Remember, that was the one that was on top. See, right here. And for that one, we're going to look at the number of degrees of freedom we have in that value. So if we had 10 measurements, we'd lose a degree of freedom, so we'd be at DOF equals 9 for that value alone. Then we come to the other standard deviation. Its variance will also be down, its degree of freedom will also be down by 1. If we did 9 measurements for that one, we'd be down to an 8. So you can see we come across the row of 8 and get to 9. Our F value for my hypothetical would be right there, 3.39. Now this one is one that's easy for me to check to make sure you're looking at the right one, because notice if you had forgot to subtract 1 to actually do degrees of freedom, you'd be a different number. If instead you had swapped the two values, so you were at 9, 8, then you would be also at the wrong value. So this is one of those cases where I can make sure pretty easily what F value you should be using and what error you probably made. So make sure you're using these tables correctly. And once you calculate that, as always, you're going to take your calculated F, you're going to take your F value from the table, and you're going to look at these and you're going to decide, has Fcalc exceeded F table? If it exceeds the table value, it's different. Remember, F table acts as a threshold, just like any other table value. So we've exceeded that threshold. We now say that these are different, meaning that we need to be using case 3. If they were not observed to be different, in other words, we had the less than symbol or even the equal symbol here, we have not exceeded F table, that means that we'd be staying in case 1 or 2, and for that we'd have to decide based on more information about our system. If you're using something with a super well-known value, we'd be in case 1. If you're still doing our normal measurement between two samples, we'd be in case 2. So that's how we use the F-test.